In this video clip, we will discuss what exactly is modulation process and what are the various ways in which modulation can be carried out. So we have discussed in the previous video clips the problems that we face if we try to transmit the audio frequencies 20 Hz to 20 kHz in their original form. Because these are low frequencies, we faced a lot of problems. So we decided to convert the low frequency signal to high frequency signal and then transmit it. This will be done through a process of modulation. The circuit which will carry out the modulation will be called modulator. So modulator input will be information signal, and the information signal is low frequency signal. In this case, these low frequencies are the audio frequencies, so I'll call it AF. The range is 20 Hz to 20 kHz. The output of modulator will be modulated waveform, and this modulated waveform will be available at high frequency. So this conversion from low frequency to high frequency has taken place through the process of modulation. In the previous video clip, we had also discussed that I will be needing a high frequency signal to carry out this conversion. This high frequency signal, which will help me to convert low frequency of 20 Hz to 20 kHz to some high frequency range, is called carrier signal. It is called carrier signal simply because it will carry the low frequency information signal and generate the high frequency signal. The carrier signal will have some high frequency, let me call it FC. So it is called carrier signal, that is simply because it is going to carry the low frequency information signal. We will put the low frequency signal into the carrier signal and generate high frequency modulated signal. So the modulated signal that we will be generating will have high frequencies, and hence it will be suitable for the transmission. Now let us try to understand how we can put the information signal into the carrier signal and generate the modulated signal. Carrier signal will be single frequency sinusoidal signal. A single frequency sinusoidal signal can be written as Vc cos 2 pi Fct plus phi, where there are three important parameters in its definition. This is called peak amplitude. So amplitude is one important parameter of any sinusoidal signal. Fc is nothing but the frequency, and phi is nothing but the phase angle. So when it comes to putting the information signal into the carrier signal, we will have three options. I can put my information signal in the amplitude of the carrier signal and generate the high frequency modulated signal. This will be called amplitude modulation. Alternatively, I can put the information signal in the frequency of the carrier signal, which will give me frequency modulation. And I can also put information signal in the phase of the carrier signal, which will give me third type of modulation, which is called phase modulation. So we will discuss all these three modulation techniques in detail: amplitude modulation, frequency modulation, and phase modulation. We will define them, we will see how to generate the signals, we will see how to receive the signals, and so on. Please remember that carrier signal will always be single frequency signal. So for example, if I carry out the amplitude modulation, we will be changing amplitude of the carrier signal. We will put information signal into the amplitude of the carrier signal. In this process, we will keep frequency and phase constant. Similarly, when I put information signal in the frequency of the carrier signal, we will keep its amplitude constant. We cannot keep phase constant because when you change frequency, the phase will also change. We'll see that later on. And when you put information signal into the phase of the carrier signal, again we will keep its amplitude constant. In this case, frequency will change. So whenever it is amplitude modulation, amplitude of the carrier will change. Whenever it is frequency modulation, it is frequency of carrier that will change. And in phase modulation, phase of the carrier will change. And when I say these parameters change, they will change with respect to information signal, and that's how information signal will become part of the newly generated signal, which we call modulated signal.